Hi, good afternoon everyone. Good afternoon. I hope you are all saying hi to me only. Good afternoon everyone. Shakuntala, Tejas, Meena, Sai Yogesh, Usha Rudra. Is my voice audible and am I properly visible to everyone? Hello Jyotir Mai. Hi Anil. Komana, hi, good afternoon. Jia, good afternoon. How are you all doing today? Harita, good afternoon. Reshma, Meena, Anivesh, Zoya. Hi Junaid, good afternoon. Ravindra, Reshma, Nikki, Prakash. Hello to everyone. Hi. Yeah, so I'll just say good afternoon to everyone and then we'll start our class. Thank you. I hope you guys are enjoying the classes. I hope all of you are enjoying the classes, not finding it too much difficult till now. Yes, Lasya, good evening, good afternoon to everyone. Hello Lohita, Sharda. My name is Anirudh. By this time, I hope you know my name. My name is Anirudh Mehta. I have mentioned it here as well. This is my name. Yes. Very good afternoon, everyone. So, in the last two classes, we have studied about what is matter, and also we have studied about what are atoms, what are molecules, what is atomic mass. I started with in the last class, right? Yes. Hi. So let us start on with the class, and I'll again talk to all of you in the last 10 minutes. Okay? All good with you? Just put a thumbs up if you are okay with it. We'll start the class. Last 5 to 10 minutes, we'll just talk a little bit about other things as well. Okay, like your future, how you are going to enjoy your BPC classes or MPC classes, depending on everything. Yes. Okay. All right, everyone. Let us start. So in the last class, I have discussed with you about what is atomic mass. These were the questions we discussed. Okay. So I talked to you about what is atomic mass. So we have defined that atomic mass tells us that how many times one atom is heavier as compared to 1/12 of a carbon atom, which we have kept as a reference. As you know, all our masses, the mass of everything is a relative mass. It's not an absolute mass. I told you that the reference that we have taken for our masses is actually 1 liter water. Okay, so when I say I am 90 kgs, I mean to say I am 90 times heavier than 1 liter water. Same way, if you want to say an elephant is let's say 800 kg, means an elephant is 800 times heavier as compared to 1 liter water. That is what we call it as a kg. Okay, 1 liter water also can be called as 1 kilogram as a unit. Same way, to define atomic mass, we use another reference called as AMU, atomic mass unit. Okay, we can convert it to kilogram and gram if we want, but in general, whenever we want to say a mass of one atom, we will use 1 AMU, which is nothing but 1/12 of carbon 12 isotope. 1/12 of carbon 12 isotope, we also call it as 1 AMU. For example, we said yesterday that if I talk about hydrogen, it is 1 time heavier as compared to 1/12 carbon. So 1 AMU, carbon is 12 AMU, oxygen is 16 AMU, and so on. Some of them we remembered. Just like atomic mass, we can also talk about what is molecular mass. Okay, we can also talk about what is molecular mass. So all of you can start writing molecular mass. Okay, molecular mass. Molecular mass by the name itself tells you mass of one molecule. Mass of one molecule, or you can say how many times a molecule is heavier as compared to 1/12 of carbon. Okay, so molecular mass is nothing but, you can call it mass of one molecule of a kind. Okay, you can also call it as algebraic sum of atomic masses in a molecule. All of you can start writing. Okay, keep your hands away from the chat box for some time. When I ask you questions, that time you can reply. But I will not explain it in Hindi. Glam Studio YouTube, please. It's a pure English class because most of you are understanding English, so I'll be explaining in that only. Okay. Please, everyone, you can stop chatting for some time and keep your mind away from the chat box. Okay. I hope all of you have been a very good student till your 10th class, and you'll behave the same in this class as well, right? So, molecular mass, algebraic sum of atomic masses in any molecule. Let us see some example. For example, if I talk about a molecule and its molecular mass, let's take an example of the simplest molecule, oxygen, O2. So whenever they say what is the molecular mass of oxygen, you have to consider oxygen molecule, which is O2. So algebraic sum of oxygen means two oxygens, each oxygen weighs 16 AMU, so it is 32 AMU, or just you can say 32 U, unified mass. Okay, AMU and U both mean the same thing. Don't keep this thing in mind that the name is atomic mass unit, so I cannot use this unit for a molecule. You can use it. There is no molecular unit. Okay, AMU only is the reference we choose. Sir, just comments you can switch off. Okay. So 32 AMU or 32 unified mass. This AMU can be used for an atom also. You can use it for a molecule also. Okay. Another one, let's take something like CO2. CO2. Let's do algebraic sum. There is one carbon atom which weighs 12 AMU, and there are two oxygen atoms, each of them weighs 16 AMU. 12 plus 32, all of you are getting 44 AMU or just 44 U, unified mass. Like this you can calculate for many of them. All of you can quickly calculate for, let's do it for glucose. C6H12O6. C6H12O6. What will be the molecular mass of glucose? Okay. So most of you would get the answer yourself. You will get it as 180 AMU or 180 U. You can just remember it from now on. Okay. Some of them will be using again and again, like glucose will be using, this is glucose. So in today's class, I'll be asking you questions mostly from glucose, carbon dioxide, water. If I check for the water, I hope all of you know that for water, you are going to get it as 18 AMU. Okay. So some of them will write here molecule and its molecular mass. You can remember a few of them, like for water, you will get 18 U. For glucose we have written. For urea you can mention urea. Urea is nothing but NH2CONH2. This is urea. All of you can calculate. You are going to get it for 60 AMU. Okay. You can remember it if you want. Urea 60 units, or you can see here 2 nitrogens. So 2 times 14 AMU. Each nitrogen is 14 AMU. Then there are 4 hydrogens, 2 plus 2, 4 hydrogens. Each hydrogen is 1 AMU. There is 1 carbon, carbon is 12 AMU. And there is 1 oxygen, which is 16 AMU. Okay. So you can check it from here that 28 and 4, 32, 32 and 12, 44, 44 and 16 is 60 units. Kindly learn these ones. And then we are going to move forward. Okay, so that is the molecular mass. Now I am asking you one question over here. Try to think it yourself and then I will solve it. Okay, question is, Can you tell me what is mass of 20? What is mass of 20 CO2 molecules in grams? I'll wait for your answer. You can answer in the chat box. You can switch on the chat box. You can take some time and tell me what is the mass of 20 carbon dioxide molecules in grams. I want the answer in grams. What is the mass of these many carbon dioxide molecules in grams? I'll give you time. Mind you, answer is going to be very, very small. In grams, I am asking. Venkat, Bhuvan, in grams. Are you saying 880 grams? I am asking in grams, everybody. 880 gram. 880 is too high, bache. Yes, you are answering 880 AMU. Yes, only one person till now has given the correct answer. Nezuko Channi, if I am writing your name correct. 880 into 1.67 into 10 to the power minus 24. Yes, only one person has given the correct answer. So options I will give you. Options are these. Options are number 1, 880. Option 2, 880 into 1.6 into 10 power minus 24. Option C, 880 into 1.6 into 10 power minus 27. And option D, 44. Let's say these are the options. Yes. So answer is 880 into 1.6 10 power minus 24 gram. Yes, correct. B is the answer. All of you can see. Those who are not clear with it, please quickly see. I'll tell you. Yes, I'll quickly tell you. Nagasai, you can also see. All of you, please see here. So, I asked you what is the mass of 20 CO2 molecules. You know that each CO2 molecule means its molecular mass. Just now we calculated it was 44 AMU. Okay, so we say one CO2 molecule, we know it weighs 44 AMU. So 20 CO2 molecules, just like you do daily calculations, one CO2 is this much, 20 CO2 will be 44 times 20, which is 880 AMU. But I did not ask you that question. I asked you what is the mass in grams. Yesterday I told you AMU versus gram. What was the relation? AMU versus grams. The relation was, those who have not attended the last class, please see the class. 1 AMU was 1.67 into 10 power minus 24 grams. Okay. AMU is a very, very, very small unit. So 20 CO2 molecules are going to weigh very, very less. Lakshmi, wait for 20 minutes. You'll be able to understand everything. Can you do that, Lakshmi? Wait for 20 minutes. You'll be able to get everything. Yes. So now our answer was 880 AMU. If I want to convert it into grams, I'll just multiply it by 1.6 into 10 power minus 24. So we can say 880 into 1.67 into 10 power minus 24 gram, which is very, very small. You can see it. The answer is in 10 to the power highly negative, means very, very small. Okay, right. Next, let us talk about the next type of mass. We call it as molar mass. Or before that, okay, now we'll talk about what is the meaning of a mole. What is the meaning of a mole? Okay, you can stop the chat. Now we'll see what is the meaning of a mole. Everyone, see carefully. Just the way when you go and buy some bananas from market, you never buy bananas in numbers like give me 4 bananas or give me 15 bananas. Generally, we used to buy bananas in terms of dozens, right? So we go to the market and we always say, give me half a dozen banana, he'll give you 6 bananas. You say, give me 2 dozen bananas, he'll give you 24 bananas. In the same way, when you talk about molecules and when you talk about atoms in general, we never say 5 atoms, 10 atoms, 20 atoms, because atoms are very, very small. Atoms are very, very small. So when I have to say how many atoms are there in this pen, I will not say the number of atoms like there are 2 into 10 to the power 28 atoms, because this is a very huge number. Who has time to count so many atoms, right? So in the same way, when you say about bananas, you talk about a unit, a new type of number called as dozen. When you have to talk about, years, you generally say 2 centuries ago, 3 centuries ago. We don't generally use it as 200 years ago, 300 years ago. We talk about a century. We talk about decade. Same way, to do the calculation or to check the number of atoms and molecules, we use the term called as mole. Okay, we use the term called as mole. What is a mole? I'm going to tell you. Listen very carefully. You might not know this before. Today you'll be very clear with what a mole is and why do we use it. Okay, what is a mole? A mole is nothing but the number of carbon atoms present in 12 grams of carbon. Okay, number of carbon atoms present in 12 grams of carbon. So you take a diamond. Diamond is nothing but pure carbon only. You take exactly 12 grams of diamond. 12 grams of diamond. In that 12 grams of diamond, how many atoms are present? We started calling it as a mole. It's just a number. See, how did dozen come into picture? Just they would have found that someday when bananas are hanging on a tree, they found that always 12 bananas were hanging together. So they said, every time when we go to buy a banana, we'll just say, give me one bunch of banana. At that bunch always had 12 bananas only. So they started calling it as a dozen, just to simplify the term. Okay. Same way, what is a mole? A mole is number of particles which are equal to carbon atoms in 12 grams of carbon. Okay, we'll find it, how much that is. But right now you learn the definition. What is a mole? A mole is number of particles or number of any substance which is always equal to number of carbon atoms in 12 grams of carbon. Okay, so mole is number of particles which is equal to number of carbon atoms present in 12 grams of carbon 12 sample. 12 grams of carbon 12 sample. Okay, we'll find it out what this is. What is this number? Let us see what is a mole now. So when I want to talk about a mole, which number am I talking about? Let us see. Yesterday I told you that, everyone, small thing. Yesterday I told you that one carbon atom weighs 1.99 10 to the power minus 23 gram. Okay, I will show you. Yesterday I showed you that one carbon atom weighs 1.99 into 10 power minus 23 grams. This is just a fact. If you don't want to remember, it's not a problem. Right now, I'm just trying to tell you where did the mole number come from. Okay, it's not very important. It's not at all important. But just if you are curious to know where did that Avogadro number come from, I'm just telling you. Okay, so we know that each carbon atom weighs 1.99 10 power minus 23 grams. Now I want to find that how many carbon atoms are present in 12 grams. Again I am telling. Can I say these many grams of carbon contain exactly one atom? These many grams contain one atom. So 12 gram will contain how many atoms? That will be called as a mole. Okay. So I am telling you, see here. So I just told you that 1.99 into 10 to the power minus 23 grams of carbon sample contain one atom. Contains one carbon atom. Okay. These many grams contain one carbon atom. So we can say 1 gram contains, this whole value will come down. That is how you use unitary method. Okay, that is how you use unitary method. What is unitary method? Unitary method means if I say to you that, let's say, I tell to you when you go to a shop, you want to buy some pens. And the shopkeeper tells you that 20 pens cost 80 rupees. 20 pens cost you 80 rupees. And in your mind you had, I want to buy 11 pens. I want to buy 11 pens. So how much money should I pay to the shopkeeper? Obviously you will not ask shopkeeper. You are smart enough. Okay, you are smart enough. When shopkeeper told you 20 pens cost 80 rupees and you want to buy exactly 11 pens, you know that you are going to pay how much rupees? Okay, I hope all of you have calculated this. You are going to pay 44 rupees. You are going to pay 44 rupees. How did you calculate this? Simple, you use something called as a unitary method. You said when shopkeeper told you that 20 pens cost these many rupees, in your brain you calculated how much does one pen cost? How much does one pen cost? You said, sir, 20 may 80 rupees, 20 pens cost 80 rupees. So one pen should cost 4 rupees. How did you get that number 4? Whenever you want to make it a unit, you always bring this 20 at the bottom here, 80 by 20. So one pen cost 80 upon 20. Okay, this is called as unitary method. So when you know that these many entities cost 80 rupees, one entity will cost how much? Bring this 20 number at the bottom, 80 by 20 or 4 rupees. Each pen costs 4 rupee. So 11 pens are going to cost 4 rupee for each into 11, 44 rupees. Okay. Same unitary method we'll be using in all the next 3 classes. Only unitary method we have to use. If you know basic transactions you do when you go to a shopkeeper, then you can do mole concept very, very easily. Just wait for first 2-3 classes because this is where I am setting up your base. Once your base is set, you'll be able to do any question within a second. Okay, trust me on this. So, clear? Same way I'm telling, if I know that these many carbons, this many gram of carbon contain one atom, then in 12 grams, how many atoms will come? So I'll say these many grams contain one atom. 1 gram will contain how many? Just bring this number down. 1 by 1.99 into 10 power minus 23 carbon atoms. Correct? This is present in 1 gram. So 12 gram carbons, 12 gram sample will contain how many? If 1 gram contain these many, 12 gram will contain into 12. So I'll get 1 by 1.99 into 10 power minus 23 into 12. These many carbon atoms. This is known as a mole. Just calculate its number quickly. 10 power minus 23 goes up, become 10 ki power plus 23. Correct? And when you, this is almost 2. 12 upon 2 is nothing but 6. So you'll get it as 6.02 exactly. 6.02 into 10 power 23 carbon atoms. These are the number of carbon atoms present in 12 gram of a diamond. Can you remember this much? Just say yes or no in a chat. In the chat, just say yes or no. Can you remember this number, everyone? This is called as a mole. Can you remember this number, yes or no? Open the chat once. Chat is on. Can you remember this number, all of you? This is known as a mole. I think chat is not on. Just check once. On. Yes. Is it clear what is a mole? 6 into 10 power 23 is called as a mole. Just like a dozen is 12, just like a decade is 10, just like a century is 100. Yes, very good, very good. This mole has another name. You can also call it Avogadro number. Because Avogadro is the person who has named it. NA will call it NA, Avogadro number. Yes. So from today, when I say a dozen pens, you will say 12 pens. When I say Avogadro pens, you will say, when I say 1 mole pens, you are going to say these many pens, 6 into 10 power 23 pens. Yes. Okay. You can stop the chat. Right, everyone. So mole is this. Once we know a mole, now we'll talk about what is molar mass. What is molar mass? Molar mass has many other names also, like gram atomic mass, gram molar molecular mass. I'll tell you all those terms as well. What is molar mass? So molar mass is nothing but mass of 1 mole of any substance. Mass of 1 mole of any substance. This substance may be atoms. This substance may be molecules. Okay. The substance may be something else also. You can take pens also. We'll only talk about atoms and molecules today. Okay. So molar mass means what is the mass of 6 into 10 power 23 atoms. Let us see what the molar mass comes out to be. For example, if I want to know what is the molar mass of oxygen atom, what is the molar mass of oxygen? That means we want to know what is the mass of Avogadro number of oxygens. So we know each oxygen is 16 AMU. This is 1 atom. I am talking about Avogadro atoms. I am talking about Avogadro atoms. Let us see how much it comes out to be. It comes out to be 16 times AMU in grams. If I want to express, it was 1.67 into 10 to the power minus 24 grams into Avogadro, which is 6 into 10 power 23. Let us see how much it is coming. Then it becomes very easy for us to understand. See everybody, 6 into 1.67, when you multiply it, it exactly become 10. Exactly become 10. And when I see 10 power minus 24 and 10, this become 10 power minus 23. And 10 power minus 23 and 10 power 23 become 1. So I am getting it as 16 grams only. So beautiful to see. So beautiful to see. What is so beautiful to see? Whatever atomic masses you have remembered, whatever the molecular masses you have remembered, just change its units from AMU to grams and it becomes molar mass. It becomes molar mass. Again I am telling. Atomic mass of oxygen is 16 and we just checked molar mass of oxygen is 16 grams. Atomic mass is 16 AMU. Molar mass is 16 grams. So every time you will see that this AMU into Na is going to become 1 gram. This multiplication of AMU into Na is always going to be 1 gram. You can see the number. AMU was 1.67 into 10 power minus 24. Na was 6 into 10 power 23. When I multiply these two, it exactly becomes 1 gram. Okay. So whenever you know someone's atomic mass, you know their molar mass already. Just unit will be different. And number of particles are going to be different. Number of particles are going to be very different. If I say atomic mass of oxygen, I am asking mass of 1 oxygen atom. 16 AMU, just one, you can't even see it. You cannot even see the oxygen atom. But when I say what is the molar mass of oxygen, I am talking about 16 gram, means Avogadro number of oxygen atom. Again I am telling you, see here, all of you. So if I talk about oxygen, it will have two types of masses. Its atomic mass is 16 AMU. Its atomic mass is 16 AMU. How many oxygen atoms are there? Only one atom. But when I say its molar mass, you are going to say it is 16 grams. How many oxygen atoms are there? There are 6 into 10 power 23 oxygen atoms. Means so many oxygen atoms are present. So there is a lot of difference between what is atomic mass and what is molar mass. Okay, what is atomic mass and what is molar mass? So many oxygen atoms. 10 to the power 23 oxygen atoms. So many oxygen atoms are present in 16 grams. So when I say what is atomic mass, it is going to be a very small number, which is going to be mass of one oxygen atom, 16 AMU. Same thing if I express in grams, then there is not one oxygen atom. There are going to be 10 to the power 23, 1 mole of oxygen atoms. Can you see once what is? Okay, so what is this? This is molar mass. So both atomic mass and molar mass will have same magnitude but different units. Both of them mean very different. Another example, if I take a molecule like water, water will have two types of masses. One is called as molecular mass. Molecular mass means mass of single water molecule, which is going to be 18 AMU. 18 AMU. Same way, water will have another type of mass, which we'll call as molar mass of water. Molar mass of water. Molar mass of water means when water molecules are 6 into 10 power 23 water molecules, that will become 18 grams. So what we need to remember right now is, whenever I am talking about molecular mass, I am talking about one water molecule only. And when I am talking about molar mass, I am talking about Avogadro water molecules. So many water molecules I am talking about. Total number of water molecules are going to be Avogadro water molecules. So many. It's like this. Avogadro molecules. Here only one molecule. Here Avogadro atoms. Here only one atom. So when I say atomic mass, it is always going to be in AMU, never express it in grams. When I say molar mass, it will be expressed in terms of grams, but the magnitude is going to remain same. Magnitude is going to remain same. Now there are other names for the molar mass, everybody. You can just write these two things. These two things you can all write. There are other names to the molar mass. For an atom, molar mass can also be called as GAM, gram atomic mass. Both mean the same thing. So molar mass has another name, gram atomic mass. Okay, both mean the same thing. Gram atomic mass means atomic mass expressed in grams unit. It is nothing but molar mass only, there is no difference. For a molecule, molar mass has another name, GMM, gram molecular mass. Gram molecular mass. Gram molecular mass. Okay. So for an atom, we use gram atomic mass. It is nothing but molar mass only. For molecule, we use gram molecular mass. It is nothing but molar mass. Same way, another thing is there. Whenever we take any ionic compound, a salt like NaCl, like copper sulfate, CuSO4, these ionic compounds, they are not called as molecules. They are called as formula units. So for them, we use the word formula unit mass. Okay. So if I take something like NaCl, sodium chloride, NaCl, or you can take copper sulfate, NaCl. I am taking NaCl as an example. For NaCl, mass of one unit will be called as formula mass. Formula unit mass, like that you can call it. Formula unit mass means mass of one NaCl unit. We call it formula unit because ionic compounds are not called as molecules. Instead, there is a new term we use for them, formula unit. One NaCl formula unit means mass of one Na plus mass of one Cl. Sodium atomic mass is 23. Chlorine's atomic mass is 35.5. You can learn this value. Okay, we'll reach to why there is a fractional number here. Later we'll talk about it. So it is, when you add them, it becomes 58.5 AMU. 58.5 AMU. 58.5 AMU contains one NaCl unit only. When I say molar mass, another term for molar mass will be gram formula mass. Gram formula mass. It is going to be 58.5 gram. Okay, 58.5 grams. Very important. You might be feeling it's very simple, but you will do many mistakes if you don't know these basics. So whenever you express the mass in grams, there are so many particles present, Avogadro particles present. But when you express it in AMU, you are talking about mass of single particle only. Is atomic mass, gram atomic mass, molecular mass, gram molecular mass, and formula mass, gram formula mass clear to everyone? Yes or no? Quickly. I can't see chat. No, chat. Okay. Is it clear to everyone? Difference between atomic mass and molar mass, molecular mass and gram molecular mass clear to everyone? Yes. Good. Very good. Now when I ask you questions, you will be able to solve them. Simple unitary method I will be using. Okay. Let's do. Okay. Everybody. Now I'll tell you how to use unitary method. Okay. How to use unitary method, and we'll be solving few problems from there. Everybody look at this. How to use unitary method. To use unitary method, always keep the known quantity on the left hand side. Santipriya is asking, sir, how to check atomic mass. Santipriya will have to learn the atomic masses. Not very difficult. I will be giving you for first few questions. Okay. Yeah. Atomic masses you have to learn only. How to use unitary method. Always keep the known quantity on the left hand side and unknown quantity on the right hand side. I'll give you a trick also to do, but always you should know how to use the unitary method. Known on the left hand side, unknown on the right hand side, and then start your question. Okay. For example, let me tell you first question, question number 1. All of you can see here, I will solve it. You don't have to worry about it. You will solve the next one. My question is, calculate number of water molecules present in 720 grams water. That is my first question. And second question is, calculate number of water molecules present in 720 AMU water. Okay, both are very different questions. 720 grams means 700 grams of water, which is nothing but almost the 1 liter water bottle, around that much. That means a lot of water molecules will come in this. 720 AMU of water is a different thing. So all of you see here. So when you see the question, when you start the question with the unitary method, always keep the known quantity on the left hand side. What is known to me? Mass is known to me. Okay, mass is known to me. So this is going to stay on the left hand side. Left hand side will be mass. And what are they asking? Number of water molecules they are asking. Water molecules are going to stay on the right hand side. This is unknown. So right hand side, I will keep number of molecules. Then in your brain, you start with your mole concept. What is mole concept? All of you please see here. Don't write anything. Don't chat among yourselves or with me. When I'm teaching, just keep your focus only on the class. Okay. How to write the mole concept? Step 1, write the mole concept. Now I'll show you how to open up a water molecule and know everything about it. See carefully everybody. How to open up a water molecule and see everything about it. Just like when I talk about a fan. Okay, if I talk about a fan, you can open up about a fan and know everything about it. Like I can say one fan contains 3 blades. One fan weighs, let's say, 800 grams. Okay, one fan has these many nuts and bolts. You can talk about a fan and you can open everything about it and check. Same way, I'm just going to open about water and going to write about it. So water is the one they are talking about. I can say 1 mole water. Let's know everything about 1 mole of water. When I say 1 mole of water, first thing you can say it's mass. We know 1 mole of water will contain 18 grams of water. It weighs how much? 18 grams. When you talk about mass, after this you talk about number of particles. As you know, water is a molecule and 1 mole always contain 6 into 10 power 23 water molecules. Correct? So you can talk about mass, you can talk about molecules, you can talk about atoms also. Everybody see here. Each water contains 3 atoms. 2 hydrogens, 1 oxygen. Each water contains 3 atoms. So 1 mole water will contain how many atoms? 3 times these many atoms. Each molecule has 3 atoms. Avogadro molecules will have 3 Avogadro atoms. So I can say it contains 3 Avogadro atoms total. Okay, I'm just talking about 1 mole of water. This is an equivalent sign. It just means to say that all of these are equivalent to each other. 1 mole water can also be called 18 gram water. 18 gram water can also be called Avogadro molecules of water. In Avogadro molecules of water, there are 3 Avogadro atoms. Correct? Like this I can write. Now, many more things we can write. We can talk about electrons also. All of you please see here, I'll talk about electrons. Each water molecule has 2 hydrogen and 1 oxygen. We know each hydrogen contains 1 electron. Its atomic number is 1. Each oxygen contains 8 electrons. Its atomic number is 8. So in a water, electrons will be 2 hydrogen will contain 2 electrons, 1 oxygen will contain 8 electrons. So H2O should contain total 2 plus 8, 10 electrons. One water molecule has 10 electrons. But here I am not talking about one water molecule, I am talking about these many molecules, Avogadro molecules. Each has 10, so I can say it contains 10 Avogadro electrons. Like this we can talk about so many things in a water. I can talk about number of protons, neutrons, but when the questions will come, that time I will talk about it. Right now, let me keep only this much. Now the question was, calculate the number of water molecules in 720 gram water. I told you, keep water molecules on the right hand side. So this is water molecules from the mole concept. I'll keep it on right hand side. I'll keep it on the right hand side, and mass I'll keep it on the left hand side. Okay. It's just like I told you, the shopkeeper told you that 20 pence you have to pay 80 rupees. Same way 18 gram contains these many water molecules, then use the unitary method. So I'm saying 18 gram water contain 6 into 10 power 23 molecules. Go for unitary. 1 gram water will contain how much? 18 will go at the bottom. I told you before. 6 into 10 power 23 upon 18 molecules. And 720 gram water is going to contain 6 into 10 power 23 by 18 multiplied by 720. These many molecules. You can write the perfect answer, or you can just write the answer in terms of Na. So I can call it as, so this is 18 40 times 40 Avogadro, I can say 40 Na. So answer is 40 Na, or when I solve it, multiply them together, you can say 240 into 10 to the power 23. This is our answer. This is our answer. Yes. Not minus 23. Yes, 2.4 into 10 power 25 also you can call it. 2.5 10 power 25. Or 40 Na is the answer. Is it clear to everyone? Just the base is clear to everyone. What are the basics? How to write a mole concept? I have told only one example. We'll do many more in the next class. Yes, yes. Same thing will be taught again. Yes. It's just a bridge class. This is not the regular classes. Okay. In the regular classes, everything will be taught again. Yes. Now I'll give you 5 homework questions. You practice them yourself. Homework questions are: how many atoms are present in 40 grams CO2 sample? I'll solve them tomorrow. What is the weight of three into 10 power 22 molecules of glucose? Glucose is C6H12O6. Calculate number of formula units of calcium hydroxide in 2.5 moles of calcium hydroxide. And fourth one, how many moles of ammonia weigh 6.8 milligram? Okay, you all try this yourself today from whatever knowledge you already have and whatever I have taught you today. In the next class, we are going to solve all of these. Okay, in next class, we are going to solve all of these. Sheikh Farid, please watch the video again, watch the previous video also in case something is not clear. Next 3 to 4 days, same thing only is going to go on. Okay, only same thing is going to go on. Yes, Harsha, yes, this concept will be explained again. Yes, problems will be only clear once you listen to the class for 2-3 days. Okay, I have just given you these problems so that you try once I'll be helping in the next class solving all these. Okay, chalo. Bye bye. Thank you everyone. Yes, this is only stoichiometry. Yes. Okay, see you all in the next class. Bye bye. Thank you.